Today we are making a small project for visualization of data from IMDB. We'll see how to get information from IMDB, how to process it using Python and Pandas, and finally style it for more interesting visualization. Today's example is for Game of Thrones and the episode's rating, but it can be customized to your liking. More on that later. If that sounds good to you, let's get started! Okay, so here is the plan. First, we'll go to IMDB to select the TV series. Next, we'll use a package named CinemaGoer to get the information about the episodes. The result contains object of type movie with basic information like title and additional details that can be requested by update. Once we have the episodes data, we'll use Pandas package to create a DataFrame. It will contain the episodes as rows and all their properties as columns. In the next step, this DataFrame should be transformed to include the seasons as columns, episodes as indexes, and the rating for their values. After that, we'll add styling to color the ratings according to their values. For that, we'll use heatmap. Finally, we'll add the generated table to an image for a personal touch. And that's it. Now that we know what to do, all that's left is to actually do it. This video is based on an article from datascientist.com. There you can find the information and also the link for Google Colab. Just use the button Open in Colab. This way you can follow along. It's a nice beginner's project and doesn't take much time to complete. The first step is simple. Just go to the IMDb site and copy the number for the selected TV series from the URL. In our case, it's 0944947. This is also your first chance for customizations. We use Game of Thrones today, but you can choose another one and select its ID. For the second step, we are going to use package CinemaGoer. It gets information from IMDb. Let's first install it. For that, we use pip install CinemaGoer. We are ready. Next, we'll need an instance from class CinemaGoer. We import IMDb from CinemaGoer and create the instance CG. Now let's see some example for the movie Avatar. Remember how we copied the number for Game of Thrones? We'll do the same, but for the movie Avatar. We pass this number as a parameter of the method getMovie of the created instance CG. Then we use the property directors of Avatar and loop on them to print their names. Let's see the result. It prints James Cameron. For the next example, we can see how to search movie by title. Let's see what we'll get if we use Game of Thrones and the method search movie for CG. Sometimes we get an error and we can try again to get the exact response. For our example project, we won't need to search by title or get the directors, but maybe these examples will help you with your versions. Now, to get the information for Game of Thrones, we'll use the same method getMovie that we used for Avatar. We pass the ID that we copied in the first step from the URL and the CG instance. If we inspect the result, we'll see it's a movie object. Now, let's try the same approach that we had for the directors. Now we need the episodes, so instead of directors, get the property episodes. Unfortunately, we get an error and that's because we only get the basic information for the series, and then we need to update in order to get the details. If we do that with the method update, we should pass the parameter series and the name of the property we want to get. Now when we execute the series and getting the property episodes, it's working. Now let's inspect the result. We see we have a dictionary with keys that are the number of the season. As the value, we have another dictionary that has keys as episodes and movie object for each episode. So we have 8 seasons and different number of episodes per season. If you want to see the seasons, we can use the method keys. And here we see 1, 2, 3, 4 until 8. If you want to see data for the 3rd episode of season 1, we can get from the seasons info first the key 1, which is for first season, and then the key 3, which is for the episodes. It returns the movie object that is for this season. Now that we have the episodes data, we are ready for step number 3, creating the data frame for the episodes. For that, we'll use a package Pandas. Let's first import it. Then, we'll gather the information for the episodes into a data frame. For that, we create an empty list and then loop first on the seasons, then on the episodes, get the data, remove the property episode of because it's a problem for Pandas, create a data frame from a list of one item using the method of Pandas data frame from records and appending it to the empty list we just created in the beginning. And finally, we can concat these data frames into the final data frame. I hope the previous examples gave you a bit of insight about each variable, but let's go one more time over it. We have the seasons info, which is the result from the episode's property. It's the example here. Then we have the season key, but we loop on the season value. So each time we have a value for one season. This is for season 1 and this is for season 2. This value comes in the season variable. Then we loop on the episodes, so each time we get a value of movie. Next, about the episode data, we can see the example for the first season and episode 3. Here we have the season, the episode and the data. Here you can see also example of the episode of property. It's an object, so it should be removed from the dictionary before we can use from records method. One more time, when we append into the list, we append a data frame with one row, which includes only one episode. Let's see the result. We have all the properties we see for each movie, and each row is one episode. That was for creating the data frame. The next step is step number 4, and it is to transform the data frame to include the episode's rating. If we see the data frame we just created, we have columns for the season, episode and rating. What we need as a data frame is a data frame with index the episode, column the season and values rating. We can do that with Pandas method pivot table. We pass index episode, for the columns we use season and the values is for rating. If you execute that, we'll see we have exactly what we expect. Here are the seasons as columns, the indexes are the episodes, and the values include the ratings. Now we can simplify the values for the ratings to include only one number after the decimal point. As you can see here, we have 1, 2, 3, 4, 5, 6 digits after the decimal point. We can use a method round and pass a parameter 1. If we execute it, it leaves only one digit after the decimal point. But if we try to style it using a background gradient, we see no longer this rounding is applied. And if you don't use the styling, we can round to the first digit and use empty string for any values, not a number. As a result, the data frame is rounded and the non-values are not displayed, or they are replaced with the empty string. In our example project, we display the rating, but if you want to customize, you can use another column, for example, the number of votes. For this, you need to replace the values with the column that you need to display. This table looks good as it is, but we can do better for our visualization. In step number 5, we'll see how to style the table. Let's examine the columns. We can notice that they have name season. If we do the same for the index, it has name episode. These are the same labels that are used in the data frame. We can remove it by setting columns name to none and the index name to none. When we display the data frame, it has only the numbers for the columns and no labels. Now, if you want to distinguish that the columns are for the seasons and the index is for the episode, we can transform these numbers to S1, S2, S3 and so on for the episodes by using the method rename. It's for the columns and uses a lambda function. In the lambda function we just append s. If you are not familiar with lambda functions, they take a parameter, the value for, in our case, the columns. So it will be first 1, then it will be 2 and so on. We do the same for the index. Again, the method rename, lambda function for the index, but this time we append episode in front of the number. As you can see, the result is as expected, S1, S2 and episode 1, episode 2. Now that we have the labels, all that is left to do is to style it with some heat map. For the heat map, we'll use background gradient and we'll pass a parameter CMap with the desired color palette. In the notebook, you can find a picture with the possibilities you can use. You can choose a palette that is suitable for your image or something that you like. If we execute that, we'll notice that we have also the rounding and not displaying the empty values, none. So for that we use the format method with precision1 and narep with empty string. This last part is exactly what we did in this step with round1 and fill NA, but so it's applied even with the styling of the gradient. For the last step, we'll need to copy the table to add to our image. But because the image is dark, we don't want this white background for the labels. We can change the settings and the theme to dark. This way, it's more appropriate for our case. But if you are using a lighter image, you may keep the theme. For the snipping, we use flame shot, but you can use another one that you prefer. So we just select the table and copy it. Then we need to open the image that we want to use in some software for editing images. Today we are going to use Inkscape and paste the table on top of it. You can use any software that you prefer for editing images. And that's it. You can create your own version using these steps. I hope you liked this project and got inspired to do your own version. If you do, please share it in the comment section down below or using the email from the description box. Would love to see your creations, and you can even be featured in one of our next videos. If you found this information useful, like and share. For more data science projects and learning content, subscribe to the channel and visit datascientist.com. See you in the next one!